Okay, we'll make a start. So certainly from the comments that are coming through, I definitely need to be addressing as good morning, good afternoon, and good evening. And so thanks to those of you who have joined us, and hopefully it won't be so soporific that it sends you to sleep. But I think it's going to be a really, really good session today. So as the title of the webinar speaks for itself, we're talking about creating electrical safety programs, but the key focus is creating ones that actually work, that are actually meaningful. So if we move on to the next slide, maybe just some little ground rules before we start. So for every single person that has registered, so those that have registered and also those that are attending today, and there's still I think we've got a record attendance, you will all receive an email afterwards with a copy of the slides and the recording of the event. And at the end of the event, when you shut down, a little survey will pop back up. We'd really appreciate you spending just a few minutes to give you your feedback on the event. It really helps us to ensure that content is meaningful and we keep the webinars engaging, and we try to take on every bit of feedback that comes through. Last but not least, so there is a chat box and a Q&A. Just any comments, any questions. I really appreciate the engagement thus far, but just put your questions in there and we'll either answer them throughout the event or we will capture them at the end. There's a lot of content for us to go through, so we'll keep moving. So what we're looking at next on the next slide is the 4 webinars that we're running as part of this program for 2022. So many of you are familiar with the program last year. Excellent feedback on these live, free to attend, non-commercial events, which I think many of you are aware of. So Skanwear is a manufacturing of arc and flame protective clothing, but I'm not sure that it's really mentioned throughout any of these events. Why? Because the purpose of doing these is actually one purpose, and that's saving lives. So the one we're talking about today is effectively we're using the Deming Ishikawa model. We made a slight variation of that on the plan, do, check, but evolve. So today is creating the electrical safety program. Webinar 2 later in the year is going to be the do part, the actual implementing of it. The following one is going to be the checking. So how do you know the electrical safety program is actually effective? How do you know that it's actually working? And the last webinar in December of this year, and it seems to be coming along fast, but that will be a bit of a round table. It'll be a new format where we're going to be having an open discussion, you may say, as to what's worked well this year, what hasn't worked well, and what new initiatives, what can we do better for 2023. Next slide. So we've got 2 brilliant speakers with us today. Thank you very, very much, Aaron and John, for joining us and for sharing the content. They'll make their own introductions, but I think the key thing I want to come across here is John is going to be kicking us off, and Leaf is working within as a consultative and a training and engineering organization. And then Aaron is going to be, his approach is going to be more of akin to a case study, where we are going to be looking at the actual physical implementation of programs within the organization within which he works and within the industry in general, particularly looking at employee engagement. So thank you very much all. And I'm going to put myself on mute. And John, it's over to you.
Thank you, Angus, and thanks everybody for joining today. Just a quick, I guess, introduction to Leaf Electrical Safety. So we're a company actually based in Canada, and we've been working, I guess, in the electrical safety and arc flash world for about 8 or 9 years now. And I guess, you know, for today's audience, what I really wanted to focus on was, especially with over the last couple of years with the pandemic, we've really, I guess, honed in on virtual training, consulting, and we even developed an electrical safety program product that is done entirely virtually. And so if you're interested in any of those, you know, you can touch base afterwards. But I think at this point, Ben, were you going to stick up that poll so we can get an idea of who we got in the audience here today? Okay, so you can just take a moment and just let us know, you know, what's the job role, I guess, that best fits you at your company or organization. And I think we'll just leave that up for a little bit there, and then able to share the results. Okay, great. So we've got a lot of safety managers, engineers, and then a sprinkling of maintenance managers and supervisors. And okay, that's great. That's a good mix, good blend. Because it might vary a little bit what I'm going to say, but I think we've kind of got to touch on everybody. I'd say that's fair. So where we're going here, I guess I was going to say this afternoon, but it could be this morning or this evening as well. Yeah. So what I want to do is I want to kind of put everybody into the mindset of the framework of a story, and just think about this and try to follow along. And that way you might grip you a little bit more. So this is really about you. So everybody in the audience today, you're a safety manager, you're a maintenance manager, you're an electrical supervisor, maybe you're a business owner, and I forget what the other one was, but ultimately everybody has something in common. And what that is that you have an organization that you're responsible for. You have a group of individuals, maybe it's maintenance workers, or specifically electrical workers. But that's kind of what holds everyone, the thread that holds everyone together here today. You've got electrical workers, and you've got something else. You've got an enemy. Okay. The problem is that your electrical workers, the ones that you're responsible for their safety, or you feel responsible for their safety, they've got to work with this enemy every single day, right? And the enemy is electricity. So before we get into the details of how to create an electrical safety program, I really want to make sure that everybody has a good understanding of what it is. I mean, it seems kind of obvious that, yeah, electricity isn't that safe inherently, but where do we really want to focus? Because what I want to do, the approach I want to take is to kind of simplify this whole thing. I'm not sure where everyone is on their journey of creating a program. Maybe you've had one running for the last 10 years. Maybe you haven't even started yet, but at any stage that you're at, you could always improve it, and you can always simplify it. So that's what I really like to do, is come up with an approach and kind of a framework and a way of thinking that will help everybody, put this into practical use. So we've got two major hazards that we're going to deal with. The first one is shock hazard. And there's a whole bunch of stuff that can happen if you were to receive a shock. It's going to hurt, possibly. You've got current flowing through your body. That's never a good thing at certain levels. It can cause burns. It can cause nerve damage. Some people report having psychological issues long-term. And so there's a whole, raft of things that you need to be aware of. But if we want to simplify our approach, because that's what we're going to do, all this information I'm going to give you is going to kind of stack on one another, and it's going to end up you'll have a nice simplified approach. So the main thing that we have to consider here is that if you get an electrical shock, or if an electrical worker gets a shock, the worst thing that can happen is that it can stop their heart. Might not be right away. Their heart might go into what's called ventricular fibrillation. It's a mouthful. Basically, their heart's not working properly. And there might be a little bit of time pass, but maybe it's 2 hours, maybe it's 20 minutes, maybe it's 4 hours, but then eventually they go into cardiac arrest. Shock hazard is actually the #1 killer for electrical workers. It's not arc flash, as most people might think it is. It's actually shock. So we really need to pay attention to shock hazard when we are building our electrical safety program. And just to kind of put things into perspective, I'm not sure how familiar everybody is with current, but most household, in North America, I think most household breakers and fuses would be about 15 amps. It's a little bit different in the UK, but you don't even need to get anywhere near 1 amp in order to stop somebody's heart. In fact, it's 0.05 amps. That's all it takes. So a very, very small amount of current can do I guess, the most amount of damage that we would ever want to happen to any of our workers. The second hazard is an arc flash. And the reason that I have an image here of the sun is because that's the closest thing I can think of. I mean, I've heard some people say that in the moment an arc flash happens, the person is actually exposed to about 4 times the amount of heat that you would experience at the surface of the sun. It's almost mind-boggling to even imagine that. And again, there's a number of things that someone's exposed to. There's a blinding light, there's a blast pressure, there's molten pieces of copper and aluminum flying at them. There's all kinds of hazards that they have to deal with wrapped up into one that we call an arc flash. But again, to simplify things, we're going to focus on the heat energy. That's our primary concern. We're going to focus on making sure that we eliminate the burns to anywhere on the body. And so there's kind of a magic number that we're going to hang around with, and it's the way that they measure what they call incident energy. That's how they measure the heat energy that comes out of an arc flash. And it's 1.2 calories per centimeter squared. Now, maybe just write that down, or you can email me after if you've got some more questions on it. But we just want to remember that number, because if you've ever seen an arc flash study done, or you've seen labels on equipment, very rarely do the levels get below this 1.2 threshold, which means, and this is how we're simplifying, which means almost every piece of electrical equipment above a certain voltage, so typically above 240 volts, it's not 100% of the time, but just to simplify things, if you're working on anything greater than 240 volts, you can pretty much assume that you have an extremely serious arc flash event that's capable. So the number is 1.2 so I saw someone in the chat there asked 1.2 calories per centimeter squared. That's the onset of a second degree burn. And I guess what I was saying is that once most industrial facilities, they operate at voltages that are higher than 240 volts, and almost every scenario you get yourself into, you're going to be working around an arc flash potential that is greater than that 1.2. Okay, so that just kind of gives you an idea of, like I said, the enemy. This is what your guys are working with on a day-to-day basis. And to really simplify it, we want to protect them from getting a shock that's going to stop their heart. And we want to protect them from being in an arc flash that's going to completely alter their life. Now, both of those can result in serious injuries. Both of those can result in a fatality. And, we were talking about this before we went live, but there's two sides of the safety world, right? There's the individual and his family and all of the impact that you're going to have there. But then the other reason that everybody's in this room today is because there is a liability on your end as a company or as a supervisor or as a manager, right? That that you're kind of in the middle of this world. You've got to make sure that you've done your due diligence to make sure that the worker stays safe. And then kind of on the flip side, if you don't, then that could come back on you as well. So here you are, kind of rubbing your forehead and sighing and wondering what you're going to do next. And I think it's, we're here because we're talking about creating an electrical safety program, or an ESP. And so everyone knows they need one of these, maybe. Hopefully everyone knows that by now. But it's daunting. The standards are confusing. The regulations are confusing. Everywhere you turn, there seems to be a different opinion about what you actually need to do and all of that stuff. And so I guess that's why I'm here today. So my background, I came from I came from mining. So I started my career as an electrical engineer, and I was working with a mining company. And at the time, this would have been almost 20 years ago, they wanted to be the safest company, the safest mining company in the world. That was their goal in like a 5-year period. And a big part of that was electrical safety. Now, at the time that they started this, NFPA 70E, I think, didn't exist. CSA Z462, I'm pretty sure didn't exist at all. And so, I kind of got thrown into the middle of this as a young electrical engineer. And, the manager kind of came to me and said, hey, electrical. I didn't know safety. Electrical. Why don't you build our program? Right. So that was kind of the start of my journey. And it was a lot of fun. And I learned a ton. But I was maybe just like some of you are right now. I had no idea like how to piece this thing together. And so it took about 10 years. It's not going to take you guys 10 years, but it took me about 10 years because I had to learn everything, right from the beginning of the standards. And I'd go to conferences and I'd learn from the experts and I'd chat with them. And eventually kind of led to this. So after thinking about this for 15, 20 years, I was able to simplify it into kind of a 3-step plan. So this will get you, I would say 85, 90% of the way there, maybe even 95. If you can put this 3-step plan into place, then there'll be some loose ends you got to follow up on, but you will have an electrical safety program that outshines most companies out there that I've seen today. Okay, so the 3 steps are this: simplify risk assessment. I'm going to show you how to do that. Focus on the workflow. So really focus on what is the work being done, and do we have all the components that we need in place to make sure that work gets done safely? And then the third thing, and this is where the program comes in place. See, most people think an electrical safety program is a big stack of documents, and you do need to have that, but that's not what makes it a program. What makes it a program is that you've got a plan in place and you are actually working that plan, and then someone's going around and making sure that the whole thing works together and you're improving it. So step 1, simplify risk assessment. So if you look at, and they actually do a great job of this in NFPA 70E or Z462, whichever standard you want to use, they're almost identical. Just high level, they look at identify, this is the process for risk assessment. Identify, and you can use this for any hazard, by the way. Identify the hazards, estimate the severity, estimate the likelihood, determine the mitigation technique. Okay. Now, what I'm going to show you here is how to simplify each one of those steps. And also on top of that, what elements of your program are going to support each of those. So identifying the hazards is actually really, really straightforward, especially if we go back to the introduction where I said we've got 2 hazards, shock, and we have arc flash. And we know we don't want to get a shock because it could cause a fatality. We know we don't want to be in the middle of an arc flash because that can cause a fatality. So at this point, we actually don't even need any thresholds. We just know those 2 hazards exist, shock and arc flash. They're going to be at every single job an electrician goes to. So at this point, we've very much simplified this approach. You actually, that's all you need to know for this step. The second step is a little bit trickier. You need to estimate the severity. So that's where now you need to start figuring out, well, what voltage level am I working at? And what arc flash level am I working at? And my speaker just decided to shut off. So what incident energy do I have? What arc flash or what voltage level do I have? Anytime we're working above 30 volts, and this is coming from the standards. Anytime we're working above 30 volts, we could have a shock hazard that could cause a fatality. I think the number one cause of electrical fatalities in North America are shocks from 120 volts. So the statistics back it up. At very low voltages, you need to pay attention to shock hazard. And so that's coming out of this. That's, just basically all equipment labels should somewhere on there have the voltage level. The arc flash one's a little bit trickier to figure out, our threshold for that. Now, I mentioned 1.2 calories per centimeter squared. So a lot of people will use that, and arguably you can look at the standards and that's what it'll tell you to do. Personally, what I look for is, can there be an arc flash at all from this piece of equipment? Because even if it was 1.1, I still wouldn't want to be standing there, because you're dealing with, like I said, you got heat energy, but there's a fireball, there's a blinding light, there's loud sound, there's molten shrapnel. Maybe you don't receive a second degree burn from the heat energy, but if you're not wearing PPE, your clothes are on fire. So that's not good. So whenever I look at estimating the severity of a certain job, I say, okay, well, what's the voltage? Well, it's above 30 volts. All right, well, that means we can get a shock hazard that could kill me. And what's the arc, or can there be an arc flash? So if the equipment is above 240 volts, and again, we don't want to get too scientific here, but for the most part, if it's above 240 volts, the answer is yes, there could be an arc flash there. And that's really all you got to know. So we just simplified those two steps that pretty much 99% of the work the electrician is doing, there's going to be a shock, there's going to be an arc flash, and then they can go to the next one. This is by far the most important thing for electrical workers to understand, is how to estimate the likelihood of occurrence, or how to estimate the chances that they are going to receive a shock, or that they are going to receive or be in an arc flash. And so just looking at the time, I don't think I have enough time to go through this all, but what I have here is training. This really is the only way to really nail this, is with training. You have to go through different scenarios, and the electrical workers just need to understand, okay, in this scenario, the chances of getting a shock are high enough that, yeah, I need to do something about it. Or the chances that an arc flash could happen are high enough that, well, we're going to have to, wear some PPE or figure out what to do. And actually that becomes the next step. It's your mitigation techniques. And I had a client the other day who actually, I was pretty happy with him, because he was the first person I talked to who said this to me. And I've been kind of saying this for a long time. When you go through the hierarchy of controls, you eliminate the hazard and you engineer it out, and administrative controls, and everyone always says, well, PPE is the last line of defense. And I've always argued that with electrical work, it's the first line of defense, because there's almost no job that, once you go through the risk assessment, there's almost no job that you're never going to have to wear PPE for. Because even if you're de-energizing the whole system, you still have to go in there and test and make sure that it's de-energized before you start doing anything else, which means when you're doing that test, you should be wearing PPE. So, back to how do we simplify the risk assessment approach? Again, once we kind of get down, so we walk through those, we've identified the hazards. We're saying we're not accepting the severity of these hazards too high. We've gone through some training, so now we know how to distinguish when the job is dangerous. So what's the likelihood that something bad is going to happen? And if we get to that point and we say, well, we don't feel comfortable working on this job without some PPE, like I said, this is, again, 99% of the jobs that you're going to come across, or the workers are going to come across. You can go through that thought process, and this is where you're going to end up. So then you got to select the proper PPEs. You also have to make sure you've got some of the right tools. So that's, again, just, is your voltage detector rated properly, and things like that. So, okay. Moving on to step 2. So this is where I said, focus on the workflow. So really, once you've established that risk assessment process, everybody understands it, then you want to make sure that you can treat every single job that any worker goes to kind of the same. So focus on the workflow. So we're kind of going to go through three things. So the first one is planning each job. Plan every single job. And we've even got and this comes out of the standards. So they talk about doing a job briefing before every job. So even if you don't have a written plan for that specific job, you can still, say there's 2 or 3 people working on a job, they can still get together and say, hey, here's what we're doing today. Plan every job. Okay. Use the safety related work practices. So there's 3 in particular, we're going to touch on them. 3 safety related work practices that are extremely important for all electrical workers to understand. So build those into your program and make sure that everyone understands them and you use them on every single job. And then the third point is complete the work competently. So, people will ask me, well, what is a qualified electrical worker? What does that mean? And it's a combination of 2 things. One, they understand the safety related work practices that are in the electrical world. And the other thing is they actually understand the job that they are doing. So just because you've gone and taken safety training doesn't mean you're qualified. And just because you've been an electrical worker for 15 years doesn't mean you're qualified. You need to have the 2 things together specifically for the work that you're doing. Anyway, so from here, plan the job. And this goes back again to the beginning. Have I assessed the risk? So you follow that risk assessment approach for every single job. Once you get to the end of that, are we going to need PPE and what is it? Are we going to need tools and what tools do we need? Are there specific procedures to follow? So this is where sometimes, and again, you can get, let's say 85% of the time you can get away with, and not get away with, but just the electrical worker will know inherently what to do. Sometimes the jobs are so complicated that once you get through the safety related work practices, then you need to have a specific procedure for that task, whatever it is. It just might be complicated, it has a lot of different lockouts you need to do or something like that. Do we have those in place? And then the last piece is, are the workers competent? So as a supervisor, say you're going to instruct a worker, hey, I need you to get in and de-energize that transformer. You are responsible to know whether or not that worker is qualified and competent to do that task. And then on the flip side, there's dual responsibility. They're responsible, if they don't know how to do it, to say, hey, I don't know how to do that. And then, there's some other mechanisms you can have in place there, but that's really what the intent is when they say competent and qualified. And just want to make sure do the people actually know what they're doing when they go to do that job. So that's planning every job. The safety related work practices, and there's more, but these are the ones that you'll come across. You'll come across at least one of them on every single job. So imagine you go through your job plan, you go through your risk assessment, you figure out what PPE you need, and then you say, okay, what are we doing? The first one you might just be doing is testing and troubleshooting. So testing and troubleshooting, it's done all the time. It's hard to have a procedure for that because you might be going in different directions every time you do it. But what everyone needs to understand is when you are doing testing and troubleshooting, chances are the equipment is turned on. A lot of tests are hard to do with the equipment turned off. You just get a whole bunch of zeros and it doesn't tell anybody anything. So the equipment's turned on. That means that we need to be 100% certain that we did our risk assessment properly, we identified the proper PPE and tools that we need, and that the person understands how to do that testing and troubleshooting. What tools are they using and are they trained in them and things like that? That's the first safety related work practice. The second one is what they call establishing an electrically safe work condition. That's just a really fancy way of saying electrical lockout. And I think there's a reason that they don't use the term electrical lockout. It's because they don't want to mix it up with maybe what you would consider an equipment lockout. When you establish an electrically safe work condition, there's two steps that are extremely important that would be over and above a normal equipment lockout. The first one is that you take a voltage detector and you actually test every single phase to ground, phase to phase connection on that piece of equipment to verify that it is in fact de-energized. So you've locked it out. You go to where you're doing the work, you open the door. At this point, you're still wearing your PPE. You get out your voltage detector and you test phase to phase to ground, everything. Now, this may change per jurisdiction, but let's just use NFPA 70E as the base point here. If it's below 750 volts, at that point, you're good. You've established an electrically safe work condition. You can actually remove your PPE and continue to work in that panel or whatever you're doing. If it's above 750 volts, there's one more step, which is applying temporary protective grounds. So that's another piece that, if that's something you need to understand how to do, you need to be trained and understand how to do it. And you probably should have a procedure in your program about installing temporary protective grounds. The third one is energized work permit. So this is another safety related work practice that you should have in your program that everyone needs to understand when we use that. So some people will say, well, geez, when we were doing testing and troubleshooting, it was all energized. So maybe we should have an energized work permit. And I've seen it argued either way. You can if you want, but you'll just be approving more work permits. When the energized work permit really comes into play, what this says is we know that people don't die of a shock if everything is turned off. And we also know people won't be in an arc flash if everything is turned off. Therefore, we are going to turn everything off as much as possible. Sometimes there will be jobs that need to get done that arguably you could turn it off. Let's just say changing fuses. There's no technical reason that you need to have the equipment energized to change fuses, but there might be an external reason. So an example is a hospital. There's people on life support and you need to work on that electrical equipment. Do you take the people off life support so that you can work de-energized? I don't know. But this is where this permit comes into place. So the permit basically says, as a qualified electrical worker, I've identified this job that I could do de-energized. However, there's another reason I cannot de-energize it. You take that to your manager or safety manager, whoever approves it, and they have to agree with you. Or it could be the other way around. The person requesting the energized work could be the manager or the supervisor, and the qualified electrical worker needs to agree. Yep, I'll do it. That's what the permitting process is for, is to make sure that everybody's on the same page. Okay. And the last, kind of piece, and I touched on this earlier, but when you look at the workflow, so you kind of go through that safety piece first. Maybe you get it de-energized, or maybe you're doing the testing and troubleshooting, or maybe you've gone through the energized work permit. Well, you still have to complete the work competently. So that element doesn't go away. You've achieved the safety portion of the work, but if you make a mistake in the technical or the hands-on part, you can now create an arc flash or a shock hazard or something like that. So, step one is getting all that safety put in place. And then the last component is making sure that the worker is qualified and competent to do that task. Very important. The last part of this three-part process, I guess, is auditing the entire thing. And the way to do that is with two types of audits. One is a field level audit. That means I've got a supervisor, and a supervisor, it could be a safety manager, or someone knows there's some work going on. So you actually go out in the field and check it out. And this could be done on a daily basis, a weekly, a monthly. You choose, you build that into your program, but you start to get that feedback every day. Are they using the safety related work practices? Did they figure out what PPE they needed properly? Do they have sufficient tools? Those are what I would call field level audits. So you want to have those done on a fairly routine basis. And then maybe, depending on where you are again on your journey, if you're just getting started, I'd almost recommend doing 6-month intervals for an overall program audit, because things are going to be coming at you so fast once you implement. But then once you're kind of up and running, I think an annual audit would be healthy. And I think the standard recommends doing one at least every 3 years. So that would be, you could have an internal safety manager perform the audit, or you could have an external third-party consultant. Doesn't really say which way is best, but you should be looking at that overall program. How's it all fitting together? Do you have the documentation? Do you have the training records and all that stuff? So with that, I think I'm out of time. I just wanted to mention, and I think at the end it'll come up again, but we do have what's called our ultimate guide to electrical safety programs. If you go to our website, I think it just pops up and you can download it. And Ben will also provide a link, I think, to everyone toward the end. So at this point, I don't know, Angus or Aaron, who wants to jump on there to do the.
Thank you, John. Excellent. We're pushing on time. That's excellent. And yep, that will be the link will be shared with the audience afterwards. Thank you, John. Aaron, over to you. Thanks for the questions.
Thanks, Angus. Yes, hi everybody, and thanks for that, John. What I'm going to do now is look at things from a LightsourceBP perspective. So just to introduce myself, I'm the O&M HV Technical Manager for LightsourceBP. And if you're not familiar, LightsourceBP is a global solar development company. We're 500 plus team members, operating over 15 countries. So mainly working on large scale grid connected, basically utility scale solar development. With a business model of develop and build, manage and operate, own and sell. And where I fit within the organization is very much within the manage and operate section. And again, as I said, operating in multiple regions across the globe. So before I jump into it too much, I believe we're going to share a poll out for everybody to quickly answer. Is your electrical safety program live and continue improved? Very good results. 83% on a yes. So, as I say, firstly, this is going to be very much about the journey that myself and LightsourceBP has been through in considering creating an electrical safety program. And the best way we decided to context this is to breaking it down into 3 areas that we consider fundamental principles. Firstly, being the legislation, what is set out in your particular jurisdiction, your area or region globally, varies slightly, but everywhere has some form of health and safety type legislation or law in place. Second part is industry learning. What lessons learned and industry knowledge and experience can you gain by looking at your industry instead of looking internally? And finally, organizational learning. What can you learn from within your organization, your internal lessons learned and continual improvement processes? So the first part, legislation. Legislation be broken down, it varies from slightly to region. I've tried to keep this as a way to explain how we've considered this globally, and it is a difficult part where you can see that some questions have come in the Q&A. Is it the same in every area? The answer would be no, from a legal perspective, where you can see here we've got some examples of the acts which are considered the primary legislation. In the UK, the Health and Safety at Work Act, US Occupational Health and Safety Act, Model Work and Health and Safety Act in Australia. These are very high level legal documents, so they don't really tell you how to do anything. They just state that here is our intent, guided by the law. The next level is the regulations. Again, it's generally considered a secondary part of legislation. The next level of documentation, which still is covered by the law and the legal aspects, but goes into a slightly deeper level of descriptions of what you must have, a bit more specific. For example, the electricity at work regulations in the UK sit under the Health and Safety at Work Act. So it's more specifically aimed at a particular area within an industry or particular task or work areas. Then you have codes of practice, generally considered not necessarily in some areas legally binding or legally required, but if you follow these standards, they give you the next level of detail down below your primary and secondary legislations to say, if essentially you follow these standards, this will help you comply with the secondary and the primary legislations overall. And these are such things as British standards, the NFPA 70, model codes of practice. There's a whole host of different documents depending on the regions that you are. And the next one down is guidance materials. Again, in the UK, HSE guidance notes, you've got in the US OSHA guidance notes and Safe Work guidance notes in Australia. These are generally there, again, to the more practical guides of, okay, it's a bit difficult to interpret primary, secondary legislations, and they give you a more practical aspect and a practical area of how you can achieve those. The important part to see from legislation is it's not where you need to finish creating your electrical safety program. That's one thing that we recognize is legislation is to be seen as very much the place to start, because it's set out by the law in your particular region, whether it's the HSE in the UK or OSHA in the US, for example. It tells you that this is required by law, but that doesn't necessarily mean that is the place where you need to finish, because there's quite a lot of other considerations to take into account that's not necessarily dictated by law and legislation itself. So that sort of moves us into the second area of looking at external learning. We've got different aspects of external learning where, depending on the industry that you work in, for an example, renewable generation, so solar, wind, onshore, offshore, and also within the UK of distribution network operators, there's such things and trade groups or industry groups and associations that have already come together as, for example, the ENA is an industry body for DNOs in the UK, where they've already came together to share their knowledge and experience, their previous lessons learned and histories that they've had, incidents and unfortunately lessons learned that have already resulted in serious fatalities and injuries, to come together to basically say, in our particular industry, what can we do to improve things as a shared area? So when you're creating your electrical safety program, you can go to these, you can search out which industry groups or associations are most applicable to your particular organization, whether that be renewable generation, working on distribution networks, transmission networks, private networks, whatever it may be in construction and maintenance. There's going to be some form of industry group association, trade associations, where you may find that they've already come together, where you can put in some lessons learned from other areas. And prevention is always better than cure. It helps you bring there's no point sitting there, and we've seen monitoring your own statistics and saying we're going to sit there and deal with our incidents and stuff retrospectively when other people have already been through this experience. So you're basically learning from other people. So some example outputs from these groups are, like I say, the model distribution safety rules in the UK, which is where the DNOs have come together and say, look, we've had lots of incidents, issues, fatalities, serious injuries over a lot of years, over decades. Let's come together and pull all our experiences and put in some model distribution safety rules of what we consider as a whole industry the right way to go. The same with the wind turbine safety rules. The wind turbine safety rules have come together as an industry of multiple companies, manufacturers, and said, here are some outputs and standards that we agree as an industry that we want to implement. And there's also others, for example, the defect reporting schemes and stuff, which all different elements of getting feedback into your organization to help you create your electrical safety program. There's also safety alerts or bulletins, again, from areas like the Health and Safety Executive in the UK, OSHA, Safe Work Australia, those legal areas where they may have had prosecutions or safety notices because they've already carried out investigations and gone where people have either had incidents or, you know, high potential incidents and those sorts of things, and where they can see trends or particular issues arise. And this one on the screen here is lubrication of circuit breakers from the Health and Safety Executive in the UK. This was released because of a noted high area of incidences and trending of the data by the HSE to be released to the industry. So again, that's another way of where you can gain additional information into creating your electrical safety program. I think a good key part where we realised that LightsourceBP is using your contractual relationships, whether you're a subcontractor to a client and you have your own subcontractors, having a good line of communication between your clients and your subcontractors, and having that two-way communication open helps not only your organization's health and safety, electrical safety programs in general, it just allows you to create a better working environment within the industry, because you're sharing obviously not just within your own organizational boundaries, you're talking between lots of other organizations, and it's shared learning again from external learning. So the third part here is what we've got is looking at your organizational learning, again, internal lessons learned. What we looked here is going through the plan aspect, same sort of cycle as what Angus mentioned in the first place, where his whole webinar series is looking at this over the next 12 months. So the best way to start is to look at this, is to put your plan together. Where do you need to be? How do you measure performance? Your legal obligations go into your plan. But again, as I said a little while ago, these need to be considered, your legal obligations, the minimum, the place to start your plan from. What are we required to do by law to set your policies, your statements of intent, and everything like that from your organization, right from basically setting the foundations within your organization. So the next stage is do. Apologies. The next stage is do. So this is where you start to implement your plan that you've already set out, where you've already understood, asking the questions, where do we need to be? How do we need to measure this? What are our legal obligations, and setting the policies? Okay, how do we now implement this? You assess and manage the risks. What are the priorities for your particular organization? Every part of this is very unique to every organization, where you step outside the boundaries of legal obligations, because how every organization works slightly different in every different industry. And a good key part of this implementation phase is the engagement and communication across your organization and with your workforce in particular. The third part is checking. So once you've implemented everything, it's gathering data, measuring performance, auditing, similar things to what John was saying. looking at active and reactive indicators as well with accident and incident investigation. All of these things help filter into the next stage of acting, gathering lessons learned, reviewing the performance of how your plan has been implemented, and what can we do to take action on our lessons learned. Some organizations are very good at, we've noticed this internally as well, where we might have incident processes, we may collate the data of measuring our performance through audits, active and reactive indicators. But how well do we action these? And we found that's a really key point to making sure that you may put down lessons learned, but it's really key to action these to filter back into the planning stage again. So we start all over again. How do we improve this? It's all about the continual improvement of your electrical safety program. And as I was mentioning here, to sort of bring it out with the data gathering in the check part of the process, near-miss reporting and investigations, they can help you determine your leading indicators of what might be causing incidents or accidents, so you can proactively deal with things instead of reactively deal with things. It's allowing you to gather that information and say, okay, prevention is better than cure. What can we do to implement into this cycle and revise our electrical safety program to prevent these from actually ever happening in the first place? Accident incident investigations, quite traditional, where obviously these look at lagging indicators. Things have already happened. So a lot of organizations look at this, including myself. It's quite typical to say, we have an accident, we need to do an incident investigation. What are our lessons learned, and implement that? But obviously, if we can use some of this data gathering through the near-miss reporting and investigation, including safety alerts and bulletins that come out through contractual relationships, as we already said, or health and safety organizations, plus audits and employee engagement, it helps us to get on top of it. So I'd just like to share an example, particularly within LightsourceBP, where we had a challenge and how we overcome that as part, which is not a whole overall electrical safety program, but it's very much a part of it, and I think it's very relevant here. So we were faced with an issue of how do we make our PPE fit for purpose, and we had to determine what was required within the UK solar O&M market. And as some of you may know, in the UK, arc flash analysis is not necessarily, it's not legally required to be carried out in the UK. But what we did have some arc flash analysis, and it gave us the worst case values that we would be facing if certain types of electrical equipment through a grid connected solar PV plant. That would be at HV to LV transformers, LVAC, LVDC, a variety, whether they be at inverters, at combiner boxes, those different things. What we found is when we looked at the categories of PPE to fully mitigate the levels of arc flash at all these different types of equipment, we had conversations with some working groups and with people within the organization say, hey, this level of PPE is what you'd need to be required to carry out this work. And in all honesty, the feedback that we received, plus discussions within the organization, is the reality of the situation is if we impose the level of PPE to cover the worst case incident energy values of these pieces of equipment, the likelihood is the employees would not actually wear it. So I think that's a very key point of where we're talking, and me and Angus have spoken before about employee engagement, is as a manager, as an organization, it's easy to dictate down, you must have this will cover you. But in reality, if people are not going to follow the procedures that are laid out, and this is something that we found through this, is that there's no point us dictating out through policies and procedures that you will wear this level of PPE when in reality they don't, because it shows that although on paper we have the situation under control, in reality it's very, very different. So the way we approach this is to pull together a PPE matrix and carry out specific risk assessments to assess the overall risk rating, which is a similar area to Jonathan was talking about earlier, where not only are you looking at the severity, but you're also looking at the likelihood and other control measures such as engineering and administrative controls. For example, hierarchy of switching. If somebody's going to be standing in front of the equipment, are there ways that we can implement remote switching to remove somebody away from the switchgear as much as possible? To consider all of these plus administrative and procedural processes before essentially having to rely on the PPE to make sure, as we said, to try and put the PPE as the last line of defense, really, to catch anything that might go wrong if we've had engineering control failures, admin control failures, and then the PPE is there to be able to catch and hopefully protect the people who are carrying out the work. So just from our perspective and in our learning in the journey that we've gone through, really, at LightSource and myself as an individual, putting together a process, I think this is a bit more from my personal perspective and experience as well, as I do feel there's very much a certain culture and idea where people say we just need to do the bare minimum. Again, I've said it a few times. I think that the best place to start is with the legislation. What must I have as a minimum for my policies and procedures? That's your starting point. Determine the accountability within your organisation. Some legislation, for example, in the UK with the HSE and electricity at work regulations, it defines duty holders who have legally defined electrical responsibilities. But even in that particular aspect, it's not very prescribed. It doesn't tell you that this person will be legally accountable for anything. It's still open to interpretation. So in the process, it's always good to define who in your organisation is going to be responsible for creating the electrical safety program, reviewing the electrical safety program, who's going to be the document owners, how can we filter all of these improvement processes back into everything. Understanding how your organisation best fits within your particular industry that you work in. Are there any industry learnings that you can draw from the trade associations, organisational groups that have come together using the example of model distribution safety rules? Is there any way that you can take some of that information and implement it into your electrical safety program? Profile your risks and structure a risk management system. Similar to what John was saying there, to be able to structure your electrical safety program and have an effective risk management system, electrical safety program in general, you need to profile your risks and understand everything that you're dealing with in your particular industry, as the risks in one not necessarily directly correlating to another industry or another organisation. A key point, again, practically engage with employees to get their input, having working groups, just having general discussions with management, visiting sites, understanding and seeing how people are carrying out jobs, carrying out work, just to try and enable a two-way communication between the employees and the guys on the ground to managers, obviously direct supervisors and line managers, but also to senior management, as sometimes the idea of management or senior management to what's actually happening on the ground can differ quite extensively. So having that engagement and a two-way communication and the cultures for people to be able to share information backwards and forwards will definitely play a key role in creating your electrical safety program. And always continue to improve and refine your program to the next level. Again, through the plan, do, check, act. It's another key point. I could probably say, in relation to the Q&A, one of the Q&A questions that I saw earlier on when John was talking, how long does it take to create? I personally don't think it ever stops being created. I think you create your minimum requirements as a base, and it's a constant revolving machine of continual improvements. How do we keep learning? How do we keep improving time and time again? And again, the next part is just employee engagement. I think that's a really key point that we wanted to emphasize. And within LightsourceBP and myself, we've sat down and we've carried out process reviews, and it's very easy to look at how can we comply and how do we improve things by analyzing data, trends, writing things down in black and white in processes and procedures. But ultimately, you get the wealth of knowledge and understanding of how a job is actually carried out by talking to the guys in the field. talking to them, what are your biggest concerns? How practical is this? Are you likely to cut corners because what we've told you to do takes you twice as long, but actually there is an easier, more simpler, and equally a safe way to do something? And the only way to really get to that is through employee engagement, having positive communication and breeding a really good safety culture within your organization. So for me, I'd just like to say really some key takeaways from what we've learned over a period of time is legislation and what is required by law is a place to start. I've said it a lot today already. Make your safety program realistic and reflective of what occurs on the ground. Employee engagement, again, another key point, as I've said a few times already. And always ask the question, what can we do to improve? Continual improvement. So just on this point here, that's pretty much the end of my sort of sharing the experiences of myself and LightsourceBP as an organisation. We put together a slide at the end here as a mind map of electrical safety program of some potential key areas that people can take away and they might find useful, of where you can see a common approach. If you look outside the legislation of a particular local country where you have legislation, standards, some key principles remain no matter where you go globally. It's PPE, training, accident investigations, learning, performance, audits. Some of these are still key areas that are applicable regardless of the legislation and the regions that you work in, and I think are very key to create an electrical safety program. So that's everything from me. Thank you, everybody.
Thank you very much, Aaron. It's excellent. I'm conscious we're just we're running to the buffers on time, so there was a lot of content to fit in. Thank you very, very much. I think a couple of key takeaways from me. One was does the theory of what we've actually got, does it actually translate to something that's practical and tangible in the field that operators can actually follow? And I think also something that we see in organizations is creating that sponsorship team, so you have engaged stakeholders within an organization from various parts, and so it's not just safety, it's not just electrical, it's not just maintenance, for example. You've got these various stakeholders who have one common goal. There's some questions that come through, so I'm going to pitch into those if that's all right. I think some of them we may have already answered. I think one of them I saw come in. John Travis, I'll pitch this to you. If you had to choose one element of an ESP program, so obviously people may have got various levels of maturity for an electrical safety program, what would you say is the most important element to focus on?
I guess just kind of going back to, where I focused, and it's really just on job planning and doing that pre-job brief with the group, and making sure before you go into any task that you have, you've assessed the risk, you have the right PPE, you have the right tools, and you know what you're doing. And it wouldn't matter to me if you had any other documents, but everyone understood the job plan and how to do the work safely. I think that would have the most impact.
That's good. Aaron, I think you touched on this. You spoke about duty holders, but in an organization, who is responsible for the creation of electrical safety program?
Yeah, I think it depends on how the organization is structured, really. I would say quite simply, the registered directors in the UK, the business owners, they're essentially people that are overall accountable for people's health and safety, but obviously they're not directly responsible for particularly creating the program. I'd say that everybody working down from that has a different level of responsibility, where you could say particularly health and safety inspectors working with electrical engineers to maybe frame out what is required, and then also the next level down of maintenance managers, electrical supervisors, how can they input into it, and everybody shares a certain level of responsibility in creating that electrical safety program.
That's good. Another question that come through was around how the best approach for the challenge as far as creating electrical safety programs. But I think, John, did I see somebody? What did you say, John? I think I saw one of your responses back was that start data collecting or start collecting information. Was that right? Or collecting the documents that are out there already? I think this is getting things together into one location so that guys have a very clear area that they can go to and a reference point. But where do you start on the challenge?
Yeah, sorry. When I answered that question, I was looking.
Okay, was that about the instant?
Well, I was thinking they were talking about arc flash studies in particular, and that's what I meant by. So it might just be a terminology thing there. In order to collect the information for an arc flash study, you actually have to go collect it. There's no tools out there to do that.
So I was thinking the question to come in regards to electrical safety program as the making a start. I'm not sure I've read the question quite correctly.
That's fine. I mean, I can answer that question as well. So I mean, well, just how to get started, and this is where, you know, Aaron and I's approach would probably differ. Mine is not to forget about the regulations and standards and all those things, but just focus on the job and then kind of branch out as you go. Just from my experience, we've had a lot more success doing it that way than starting sort of at the regulation point and you try to map out everything, and it just, you know, sometimes becomes very overwhelming. So that's I guess what I would recommend doing.
I think just on that point, just from my observation and having to do with the industry, is goes back to Aaron's point as well, as getting into the field and working alongside the guys and watching how they're currently following processes at the moment. I mean, simple things that I've seen is, you know, copying and pasting of template, put, you know, point at work risk assessments. It's, you know, it's a document that's being commonly used in an organization, and you see the same document being used for multiple tasks, even though the hazards actually vary. But it's just something that's always been done, which when I think involving the actual workforce in the creation of it. And it also goes back to the question that's been asked in regards to PPE, how to encourage workers to wear full PPE, hard hat, gloves, safety glasses, etc. I think that always starting with the engineer in mind and involving them in the process, I think you'll get that buy-in and you'll get invaluable feedback and help. And I don't believe it should be an encouragement point as far as making people wear PPE. I think it should be put away, across in a way that it's attractive, because I believe that what's provided and the consultative way that you talk to your people is something that they actually want to embrace, something they actually want to adopt, and they want to have input in helping the organisation be safer. Sure, there's a lot of questions coming through. Copy of NFPA 70E is a purchase document. I think we've covered jurisdiction. I think one of the questions, otherwise I think we have to wrap up. So one more question here is training and competency, John, something that's accounted for?
As part of the program?
Yes.
Yeah, I mean, definitely. I would have an entire section on training. And the way I would look at it is not only what are those safety related work practices that we need, but I'd also go as far as to say, what are the specific work tasks that the electrical workers absolutely need to know how to do. And I'd have a training matrix for my whole team that would show, you know, everything they're capable of doing. And you know, you don't want to make it thousands of pages long, but there's probably 5 to 10 extremely important procedures that they would all require training and proof of training on in my books.
That's good. Listen, I think we're heading up towards 15 minutes overtime, so I'm conscious of that. So I'm sorry if I've not managed to answer every single question that's come through. I do think one of the suggestions, which you'll have all seen in the chat from one of the attendees, is in regards to remote switching. And we should be well aware that once you've identified the risk, of course, the first priority is to try and engineer out the risk and do anything that you possibly can to put people at a distance from the risk. Distance is your friend. And then when it comes to electrocutions and isolations, there are new innovations that are out there these days that even after carrying out the isolations, there's wearables that you can have which are going to give you some indication as to whether there is still any presence of energy, which is giving your guys warning that what they're going into is still live or is not correctly isolated. But Aaron and Jonathan, we could go on for a long time, but I'm bothered that when we promote these webinars, we say that they're 1 hour, and I don't want to eat into people's time. So with that, everyone, I want to thank you very, very, very much all for attending. Really appreciate the engagement, and the recording will be sent out, as I've already said, and we'll be hosting another webinar moving on to the do, which is the actual implementing of the electrical safety programs in a couple of months' time. So with that, we'll love and leave you all and keep on with the journey, saving lives.